time on this, but yeah, I'm just a backup flat earther here for now. So my point is that the Bible teaches flat earth, and I believe in the Bible. So there you have it. Yeah.
Okay. Rids, you want to start, or you want us to go to the Bible nerd and see if we can suss out where these passages are?
Well, it seems to me like the guy doesn't actually follow evidence. It's just the Bible says so, therefore it's true. So it's not really my brand of flat earth, but I guess I can ask a simple question. Sure. Do you by any chance know of a company called Blue Origin?
No, I don't think so.
Okay. Blue Origin is a company that is doing suborbital launches for the public. And this means that you actually get to go past the Kármán line into trajectory into space, and they actually experience, I think it's 5 minutes of complete weightlessness. So if I were to get you a ticket on this suborbital rocket known as the New Shepard and fly you past the point of which you would actually be in space, and you would see the curvature of the Earth, and you would experience weightlessness and all that jazz, would you come back to Earth still believing that the Earth is flat, even though you actually saw curvature directly?
Okay, now if we go with what if and when, we can go on. I can ask you when and if unicorns start shooting diamonds, will you wear diamond rings? You see? Now, obviously, if you want to go with the if, then yes. If I would see it, then yes, of course, obviously.
Okay, so that is if you're able to see curvature directly, then you would believe curvature, and then would you accept that the Bible was incorrect in teaching flat Earth?
Again, if we go with the if, we can, yes, sure. If and when,
okay.
We can go anywhere with that, my friend.
Perfect. So now what if, and this is, again, if, just sticking on if,
another if.
we were able to do something just as good or just as compelling or just as convincing, just as valid, like, for example, all the observations that myself and my friends have been making over the last 3 years, would you fall into that same conclusion? Would you be of the opinion that the Bible is incorrect in teaching flat Earth?
Again, if we go with ifs, we can talk about if all day, my friend. So you either make a point or we go with the if again. So.
Well, I just want to see if you're going to be intellectually honest.
I can ask you if when you die you see God and you see the flat Earth, will you then believe it's flat? See, I can do the same game. We can play the game if you want.
Yeah, I know we can do the same thing, but I'm just trying to see of the type of Christians that would go so far as to say, I don't care if you were able to jet my ass into space, I still wouldn't believe even if I'm looking at it. Because there are people like that exist. Because if you were one of those people, then I wasn't even going to have a conversation with you. I was just going to say that you're a dipshit and move on with my life. But since you are one of those people that would change... Yeah, if you are one of those people that would change your opinion in the evidence, then I guess I have to ask you, why don't you find the evidence of the flat Earth convincing? Or the evidence of the round Earth convincing, I should say.
Okay, well, again, I believe there's a line that is very thin between science and scientism. And I believe that Big Bang to evolution and everything in between is scientism. This is my opinion, right?
That's fine. I love We're not talking
real
about that,
science. And I know. I'm just pointing here that there's a line between scientism and science. I love real science. Okay, if you give me real science, then that's all good, my friend.
Okay. Just talking about the geometry of the planet. Can you please explain to me how we have two celestial poles in which the stars rotate that are invisible to the opposite hemisphere?
Mm-hmm. Yeah, I mean, first of all, you make an assumption that the Earth is a planet, right?
No, I didn't say planet. I just asked you, why do we have two pole stars in which the stars rotate, which is...
You said the Earth was a planet. I heard you. Okay? Now,
Okay,
can
then
you
let
give me
me
the etymology of the word planet? Because you're
Then let
using a
me.
word I don't think you understand.
The feeling is mutual, but let me go ahead and rephrase it so that I don't
Can
use
you
that
give me
word.
the
Then,
etymology of the word planet?
so let me rephrase without using the
You
word, so
don't
it's
know
no
what it
longer a
means?
problem. So I'll go ahead and concede. I don't know what it means.
Okay.
Now let me rephrase so that I don't use the word. So again, can you please explain to me how we have two pole stars in which the stars rotate that is invisible to the opposite hemisphere?
Perspective.
What is perspective?
Well, obviously, the sky as a giant dome over the flat, right? There's a limit to what you can see. So there you have it. Okay, easy as that.
That doesn't tell me what perspective is. What is perspective?
The things you see and how you see them.
Okay, that's still not answering my question. You're saying things you see and how you see them. What is the how? Do you have a mechanism? Do you have anything like that?
Again, I told you, perspective is the reason why you either don't see all of the stars or see what you see.
Okay, I can just as easily say flippity-jippity is the reason why you don't see the stars and the stars you see. Do you see how that gave me absolutely nothing to go on?
Yep, I saw that.
Okay, so please correct yourself then. Please tell me what is perspective, if it is a solution to this problem of yours.
Again, I think you've heard that many times. I've heard you many times. Okay, perspective allow you to see what you see, where you see it, and that's the reason now.
Okay, maybe I should rephrase my question. How does perspective work?
Well, it's what you perceive with your eyes.
Okay, that doesn't tell me how it works, though.
Well, then explain it to me. I mean, I don't know.
So you're asking me to explain your position?
No, I'm asking you to explain to me perspective. You want me to explain to you perspective? I can ask you the same question. Explain perspective to me. You see, it doesn't prove flat or round at this point. It's just perspective.
No, I'm actually just trying to get your definition of perspective. It seems to me like you're using the word perspective as a catch-all solution, but you don't actually know what perspective is.
I mean, we could do a Google. If you want a definition of the word, I don't mind. You see, perspective. We can do that.
So you accept the Google definition of the word perspective?
Yes. I don't make the definition of the words I use.
So basically, only Google.
No, but I think Google is correct on the definition of perspective. An outlook, a viewpoint, a point of view, a standpoint, a position, a stand, a stance, an angle, a slant, and I can keep going.
Okay, so none of this is actually limiters to why we shouldn't see the southern celestial pole from the northern hemisphere, because the same rules.
So you think there's no limit to what you can see? You think you can see infinitely?
I think I can see a
because
southern celestial
that would be
poles.
Convenient.
I think I can see
Okay,
southern
can see
celestial
stars
poles. Yes,
rotating. You can see
around a
stars
fixed
rotating.
point. Yes.
Yeah, in the south, but there's no actual stars there. There's no actual south point there, right? South pole there. The stars are rotating. Yeah, I give you that.
Yeah, it's despite the fact that we actually have observations that show a southern celestial point.
There's no star there.
I'm not talking about a star being there, but there is
south star.
There doesn't have to be to have a southern celestial point.
I understand that.
So why even bring that up then?
Well, because I'm telling you that they're not rotating around a star like they do in the north, like Polaris. They appear to rotate around a point due to perspective. But there's no point there.
They appear to rotate around a point because they're actually rotating a fixed point in the sky.
somebody gave me that. I don't remember the exact, but he told me to Google it, and I Googled it, and the first thing that came out was the imaginary point. I mean, if it's imaginary, then there's no point there. I give it to you. The stars are going in a circle around no stars there.
Correct. So why is the southern celestial point not visible to anyone in the northern hemisphere?
Because of what you can. You're limited by your eyes and everything else.
What defines our limits? What makes it? What is the limiting factor that prevents us from seeing the southern celestial point?
Well, many things. Distance would be the greater one. Now, obviously, the atmosphere and all of those things would be another fact. I mean, some days you go out, you can't even see the other side of the street. So,
okay, so
there's a limit to what you can see.
Okay, what defines that limit?
I just told you. You want me to tell you again?
Please do, because I don't think you answered my question.
Distance.
Okay, how does distance play a factor in?
There's a limit to what you can see due to distance.
Why?
Okay, you cannot zoom infinitely.
I can
First
see
of all, we don't have powerful equipment. Your eyes are not powerful enough, and again, there is some water in the air, other things. I mean, you might think there's nothing between you and your computer screen, but there's a lot of things there.
Correct, and yet I can still see the moon past all that supposedly dense medium. So what's the issue here with the southern celestial point?
You assume the moon to be super far away, and
I never said that.
But in my model, it's super close, so there's no problem seeing the moon.
Well, actually, there is a problem with the moon being super close in your model, but we will touch on that contradiction later. The point is that even in your model, the moon is also super far away, relatively speaking. So if the moon is also super far away, relatively speaking, and the southern celestial point is also super far away, relatively speaking, and so is the northern celestial point, especially where I am in mid-Florida, relatively speaking,
Now,
then why is the southern celestial point? Why is the southern celestial point so special that equation?
I just told you, you can see Orion from everywhere, just as you can see the moon from everywhere. Okay?
Okay, so I can't help but notice that you're answering my question. I think you're using perspective as a catch-all solution without actually knowing what perspective is.
Can we get an actual working definition of which
perspective is a mathematical equation. Perspective means alpha equals 2 times the arctan of g over 2r, where alpha is the angular size of the object, g is the actual size of the object, and the distance to the object. Now, via using the actual definition of perspective, where is the limiting factor in that definition that applies to the southern celestial pole, but not the northern moon or the sun for that matter? Because give this a taste. The southern celestial point has more than enough angular resolution that we should be able to see it easily, but yet we don't. It disappears beyond the horizon. And also following the fact that parallel lines do not intersect by definition, we again have another contradiction with the flat Earth model, because via the flat Earth model, we should see it easily from everywhere, yet we don't.
Can you see Orion?
Yes, I can see Orion.
From everywhere?
Not at the same time, no.
But you can see it from everywhere?
Not at the same time, no. Not on the round Earth model.
But you can... I understand. Okay, but you can still see it from everywhere, correct? Just like the moon. You cannot see it from everywhere at every time, but you can still see it from everywhere.
You can still see
correct?
It, yes.
Exactly. So there you have it. You can see Orion from everywhere. You can see the moon from everywhere. You can see the sun from everywhere, but not at the same time.
Good. So why the southern celestial pole can I not see it at all from the northern hemisphere?
I told you, it's too far away. It's beyond the equator. It's too far away.
Why is it too far away when the angular resolution of the southern celestial point from our distance would be bigger than that of the moon? So why is it that I have
From the
enough
south,
angular resolution
light
to see the
to
moon,
north,
but
you
yet
can
I
see
don't